Hello everyone and welcome. In this video I'm going to show you how to do a single sample t-test using SPSS. In this case I'm using version 25, but these instructions should work with any version of SPSS that you're working with. So in this case we have a very small sample with just 12 people. This is coming from activity 5.3 in our textbook. And one reason we have this small data set is just if you wanted to compute it by hand and compare your results to SPSS, you could, but also it helps you see the limitations of using small data sets as well. So in this case, we're looking at people's confidence in their driving abilities. They're rated on a 7-point scale, where 1 is they think they're below average, 4 means that they think they're average, and 7 means that they think that they are above average. So what we're wondering is, are people biased in reporting their confidence? If they're not, we should end up with a score of 4 on average. Right? Now, because on average, people should be average drivers. If it's higher than 4, they're upward biased. If it's lower than 4, they're downward biased. So we're going to do a single sample T by clicking on Analyze, Compare Means, and we're going to do a one sample t-test. I'm going to move driving confidence over into the test variables box. Now, the test value is set at 0, but that doesn't make any sense for our comparison. Our scale ranges from 1 to 7. Of course, we're going to get a number that's different than 0. What we want to know is whether or not our mean is different than 4, the midpoint of the scale. So I'm changing that to 4. Okay. Otherwise, that's all you need to do to run the one sample t-test. You click on OK. And you can see for our t-test, we have 12 people who gave an average score of 4.58 with a standard deviation of 1.17. The standard error is 0.336, which is the standard deviation over the square root of n. Our t is 1.73 with a p-value of 0.11, which is a two-tailed p-value. This is great because we happen to be using a two-tailed test here, but if you were doing a one-tailed test, you would divide that value by 2. The difference between the mean of 4.58 and 4 is 0.58. And we're 95% sure that the true mean difference is somewhere between negative 0.16 and 1.32. Right? This is a really wide confidence interval. And the reason it's really wide is because we have a very small sample size. Right? So in this case, our p-value is 0.10, very weak evidence against the null, very wide confidence intervals, indicating to us that we can't really draw firm conclusions for this. This study should really be replicated with a larger sample size. All right, to get graphs of the data, you can click on Analyze, Descriptive Statistics, Explore. I can move driving confidence over there to the dependent list, and then under plots ask for a histogram. And that will give me actually a histogram and a bar or a box plot to look at. All right, so that is all you need to know to run the data and analyze it using the single sample T in SPSS. Now, SPSS does not give you the standardized effect size. Right? It doesn't give you D, and it doesn't give you the confidence intervals around that. We have other videos showing you how to do that if you are using SPSS. Okay, so that is all you need for this activity. I hope that helps, and good luck.